Alright, looks like we are live. Let's continue. Let me open the table of content first. Okay. We are still on chapter 21. Beyond physical memory mechanism here. Let me pull that out. Yeah, basically put swapping to this or something like that. Oh, okay. There are a lot of questions here. Well, let me read the readme first. Okay. What is it beyond? Okay, I think this one. Right. Introduce you to a new tool, VMstat, and how it can be used to understand memory, CPU, and input-output usage. Read the associate readme and examine the code in mem.c before proceeding to the exercise and question below. Okay, in this homework, you will be investigating swap performance. Oh, okay. Swap performance with a simple program found in mem.c. The program is really simple. It just allocates an array of integer of a certain size and then proceeds to loop through it repeatedly, incrementing its value in the array. Okay. Type make to build it and look at the file make file for the test about how the build works. Okay. And then type .mem followed by a number to run it. The number is the size in megabyte of the array. Thus to run with a small array size 1 megabyte, we do this. Oh, okay. So there's an argument here. Alright, and to run with a larger array, 1 gigabyte, something like this. The program prints out the time it takes to go through its loop as well as the bandwidth. In megabyte per second, bandwidth is particularly interesting to know as it gives you a sense of how fast the system you are using can move through data. Oh, okay. How fast the system you are using can move through data. On modern system, this is likely in the gigabytes per second range. Here is what the output looks like for a typical run. Allocating. Oh, okay. 1 megabyte. number of integers in array. Oh, there's number of integer in array. Interesting. And there is a bandwidth too. Okay. The program first tell you how much memory it allocated in bytes, megabyte, and in the number of integers, and then start looping through the array. The first loop in the example above took 40 to 448 milliseconds because the program accessed the 1000 megabyte. Okay. In just half a second, the compute bandwidth is not surprisingly just over 2000 megabytes per second. Okay. So this is the time it took to loop, I guess, this amount of array, or maybe yeah, I need to see the code, I guess. But for now, I assume not that one. This number is, yeah, this time is for going through this number of integer in array. But yeah, maybe the number of integer in array is split between loop. Maybe. So yeah, there is some other possibility. So we need to check that out. Okay, the program continues. Then start looping through the array. Okay. The program continues by doing the same thing over and over for loops 1, 2, etc. So I assume, yeah, the previous assumption, I guess, that we looping through this amount of array or elements, I guess. Maybe. Important to stop the program, you must kill it. Okay. This task is accomplished on Linux and all Unix-based system by typing Ctrl+C, as shown above. The --C here. Note that when you run with small array size, its loop's performance number won't be print. With small array size, its loop performance member won't be print. What? Oh, something like this. In this case, the program program only prints out a sample of outputs, so as not to flood the screen with too much output. Oh, only a sample of output. Okay. The code itself is simple to understand. The first important part is a memory allocation. Okay, right. The big memory allocation happens here. Okay. Then the main loop begins. Oh, using while. Okay. Main loop of loop done here. Okay. The rest is just timing and printing out information. C mem_c for the tile. Much of the homework revolves around using the tool vmstat to monitor what is happening with the system. Read the vmstat main page. Again, type main vmstat, the manual page, for to tell how it works and what each column of output means. Alright. Let me take a look at the makefile. Oh, okay. We're using this instruction, I guess. Alright. Oh, there is uppercase O. I think it is some kind of optimization, right? Or maybe it is the basic optimization. Okay, I think this one. Optimizing compilation takes somewhat more time and a lot more memory for a large function. With the test uppercase O, the compiler tries to reduce code size and execution time without performing any optimization. That takes a great deal of compilation time. Test uppercase O is the recommend that the optimization level for large machine generate code as a sensible balance between time taken to compile and memory use. Higher optimization level perform optimization with greater algorithmic complexity than at test uppercase 0. Oh, okay, so this is the optimization. Is that the default? I don't think that is the default. Yeah, I think this one is the default. Completely disable most optimization, right? Okay, so we have some sort of optimization here. Alright, now let's take a look at this one. Okay, simple routine to run absolute time in second. Okay. Oh yes, we are casting that. Okay. argument count is not equal to 2, okay, print this and then exit. Alright, okay, allocating that malloc, check if malloc return null or not, okay. Number of integer in array, size in byte. Okay, and then size of integer, okay. Get second. Now the main loop is time through. Is time through touch its integer and increment its value by 1. Okay. X. Wait a minute. Did we initialize X? I don't think we initialize X, right? So this element might have whatever previous value, I guess. Okay. If you have gone through the whole loop, resets a bunch of stuff, and then perhaps print out some statistic. Some double delta time get second, okay. Only print every 0.2 second. Okay. Time get second, okay. Beyond, okay. Right, and then yeah, we got that. This error, right? Because the argument count is not 2, and I guess we will also get an error if we provide more than 2. And yeah, we also counting this executable. So this is argument 0, I guess, and this is argument 1. This is argument 2. Something like that. Oh, interesting. Loop count. Why is loop count something like that? Is it consistent too? No, not consistent. Alright. Okay, and small array size. Let's try something like this. Oh, interesting. Is that time senseless spring? Okay. I equal num ins. Yeah, I'm kind of curious why the loop indicator here is different. Okay. If you have gone to the while loop, recess a bunch of stuff and then perhaps print out some statistic. Okay. Number of in. Okay. Loop count. Maybe because we only print every 0.2 second. Maybe. Yeah, that make me curious. Oh, okay. Oh, I see. So we went to, what is it called? When the provide to provide bytes, I guess, or the allocation here is small, we skip through this part. time, what is it called? By the time we are printing this, the loop count, which is also increment here, already this much. Okay. Alright. So if the number of integer in array is small, we what is it called? We keep skipping this, and then the loop count is keep increasing, something like that. But if the number of array is big, I guess we can hit that every few seconds, maybe something like that. We are only skipping 2 in this case, at least. Okay, interesting. Let me check the VM stat. Report virtual memory statistic. Okay. Okay, VM stat report information about process, memory, patching, block input output, traps, disks, and CPU activity. The first report produce give average since the last reboot. Additional report give information of sampling period, of length delay. The process and memory reports are instantaneous in either case. Delay, okay. Alright. Let's check the question, I guess. First, open to Spirit terminal connection to the same machine so that you can easily run something in one window and the other. Now in one window, run VM stat1, which shows statistic about machine usage every second. Okay. Read the main page, the associate readme, and any other information you need so that you can understand its output. If this window running VM stat for the rest of the exercise below. Now we will run the program mem.c, but with very little memory usage. This can be accomplished by typing /mem1, which use only 1 megabyte of memory. How does the CPU usage statistic change when running the mem executable? Do the numbers in the user time column make sense? How does this change when running more than one instance of mem at once? Okay, so here, maybe because if we, what is it called? If we put a small number here, small number of memory, it kind of fast that we keep missing this when we are looping through what is it called, looping to the number of integer here, right? So that's why the loop count is kind of weird, something like that. Number of update in absence of count when delay is defined, default is infinite. Oh, okay. Delay between update in second. So we provide delay first and then count. Let me try VM start 10 maybe. Okay, interesting. Oh, I see. Okay. Running this. And then running this. Okay, let's try with 10 count, I guess. Yeah, I will stop this. Okay, let's check. I'm still not sure how to read this information. Okay, well, let me check the main page, I guess. VM start. Active display. Active and inactive memory. Given a 2.5.41 kernel. Oh, is this only in the Linux? Maybe. And then Fox, switch display, the number of forks since boot. This includes the fork, vfork, and clone system call, and is equivalent to the total number of tasks created. Each process is represented by one or more tasks depending on the thread usage. This display does not repeat. Oh. To the total number of tasks created. Okay. Snap info. I am still not sure what snap info is. Okay. One header. Display the header only once rather than periodically. Do we display the header periodically? Interesting. Yeah, monitor. It looks the same to me. Yeah, what is the difference here? I am not sure. Okay, start display a table of various event counter and memory statistic. Report this statistic. Okay. Report some summary statistic about this activity. Okay. Partition device. Unit character. Timestamp wait. Okay. Oh, wait output mode. Useful for system with higher amount of memory. Okay. Put partition, put unit, character. Okay. Timestamp to each line. Okay. Wait. Oh. Yeah, that is very wide, I guess. Omit first report with statistics system put. Okay. Right. Field description for VM mode. That's what we need. And probably we need to append the timestamp. Right. Probably. Well, let me is my custom keep binding in here too? I don't think it is. Alright, I need to check the key binding. Yeah, I have some key binding that I forgot. Where is it? Okay, I think this one, or maybe this one, even vertical. Maybe. Yes. Alright, that's what I want. So So instead, side by side, I want this to be top and bottom, I guess. Yeah, I kind of forgot the key binding. Okay. Okay, should I use 5? Yeah, 5 is fine, I guess. Okay. Switch output between 1K. Okay. Oh. Should we also change the unit here to make this easier to understand, I guess? Using M to make a byte. Maybe not. Okay, well, let's use that. Okay. Let me read this. Procs the number of runnable process running or waiting for runtime. Oh, I assume this is some kind of the state after block, I guess. So we are not necessarily waiting for input output unlike this one, right? But it is still waiting for the process to run. If I remember correctly, we are learning about that in the scheduling, I guess. Maybe in this chapter 7. Let me pull that up real quick. Where is it? There's no diagram. I feel like there is a diagram or figure to represent about the scheduling. Maybe not on this chapter. Maybe in this one. Let's see. Yeah, basically there is a representation of the state. So there's a block state, there's a runnable state, something like that. Maybe not in this chapter too. Yeah, I kind of forgot on which chapter it is. Or maybe it is chapter 8. Maybe not. Okay, yeah, I forgot on which chapter it is. But basically, there's this process that running, and then there is what is it? The block state, and then after that, runnable or something like that. Basically, after we turn the input-output, waiting CPU to pick this up. Yeah, I just don't remember on which chapter we are talking about that. I think it is chapter 7, but I might be wrong. Or maybe I just skip that. Oh, okay. Maybe not in the figure, but just a simple explanation. See, there's a block state here, waiting for input-output to complete, and then after it is complete, we are waiting for the CPU to pick that up again. Yeah, something like that. Okay, so this is the runnable process, waiting for the CPU to pick that up. And this is number of process block, waiting for the input-output to complete. Okay, this one, and then memory. These are affected by the unit option. SWPD, the amount of swap memory use. Oh, okay. Free, the amount of idle memory. Okay. Buff, the amount of memory use. Buffer, and then case, the amount of memory used as case, and then there's also inactive case, the amount of active memory if we use test A option here. Then test also active, the amount of active memory. Alright, wait a minute. Yeah, this make me wonder, what is the default unit here? Is it byte? I assume that this is byte. This representation here. Maybe. Okay, and then swap. Affected by the test unit option to amount of memory swap in from this. Amount of memory swap to this. Okay. So I assume the SE here means that we get the memory from this, right? We swap in from this to the memory, but this one SO we swap out from memory to this, something like that. Okay, and then this one IO, input output, maybe keep it byte, right? Receive from a block device, and then keep it byte send to a block device. Okay, this is receive and this is send, or maybe write to a block device. Okay, can we think of this as read? Like this is the read status, maybe something like that, and this is the write. I'm not sure. System in NCS, the number of interrupt per second including the clock, the number of context switch per second. Okay, interesting. CPU, there's a percentage of total CPU time. Time spent running non-kernel code. Time spent running kernel code. Okay. Time spent idle. Okay. Time spent waiting. Time stolen from a virtual machine. Time spent running KVM guys code. Is this virtual machine like QEMU or something like that? Maybe. Okay. Hello, first movement. Keep the mic a bit away. We had to start audio. Okay. Is this fine? Oh, hello Luigi. Welcome. Okay. This our percentage of total CPU time. Alright. For description for this mode. Description for this mode. Read and write input output. Alright. Well, you know what, let's continue this on the next session, I guess. Yeah, I need to understand more about the VM stat here. Okay. How do the CPU usage statistics change when running MEM? Yeah, let's explore this question on the next session. So that's it for now. Thank you for watching and see you next time. Bye bye.